Okay, so before the break, we were just kind of clicking around, looking at different things on GitHub, sort of introducing it. It's a big, powerful tool we use in software development, so you'll want to get familiar with that eventually. There's an assignment in it, but the assignment is very, very basic level. When I put things together, I had to copy and paste from somewhere, copy and paste it from somewhere. And I did not know how much exposure different people have had to repositories yet. So it's very basic level. Feel free to do more if you're already somewhat familiar with the repositories. Try to expand your knowledge. They're big, powerful tools that we do use quite a bit. They get used extensively in software development. That wasn't the only thing that we have for this week. This, like I said at the beginning of class, I guess an hour and a half ago now, we've pretty much finished the Python part. Might come back and add a GUI, look a little bit more at GUIs, because your final project will be written in Python with a GUI. But this week and next week is sort of some random odds and ends, different things to look at. So one of those being repositories. It's not directly writing code, but it's a tool we use to develop software. The other big thing this week, if I go back to the modules and take a look at this, is we're going to look at other programming languages. So you'll want to look into other programming languages, and a small assignment has not been, you'll notice there's no programming assignment yet. There's going to be a programming assignment that will show up by Wednesday night, Thursday morning at the latest. After our class on Wednesday, there will be a small programming assignment on there. I was waiting until we got to the module 6, and same thing for module 7. I was waiting until we actually had a class on those modules before writing the homework assignment to see what all we covered. So there will still be a programming assignment. It'll be kind of a small one, and the one for this week is going to be in a language other than Python, because we've already seen Python. We've already finished our coverage of Python, though we might come back and do a little bit more. So first thing we need is a place to type our code, right? Or some sort of integrated development environment. And my recommendation for the looking into other languages will be to use a cloud-based IDE that knows a lot of languages. So a very common one is Ripple or Repel, however you want to pronounce that word, repl.it, which is actually their old address, but when you type that, it'll forward to the new one, replit.com. The old one is, I committed to memory quite some time ago. So online IDE, a lot of the stuff we would expect from a cloud, multiple people can work at once, different chat rooms, different ways to share, a lot of the collaborative features we would expect with cloud stuff. But it knows a lot of languages. If we scroll on to the bottom here and just kind of look through here, that's not even the exhaustive list. That's just the most popular ones. And it's kind of a long list of languages that we can type in this IDE. And this week, that's what we're doing. We're looking at other languages. So I would recommend using this. If you haven't set up an account yet, you'll want to set up an account or just log on with something else that you have an account for. You do have to set up a GitHub account for your other homework assignments. So that might not be a bad one to connect here, because this will sync with your repository. You can connect them directly. I just have a regular account, so I just log in here. I think we've looked at this a little. They have some social features, So you can do the online socialization, social media sort of thing, connect with other programmers around the world that also use this and see examples. There's a tab over here that says learn. So there's tutorials built right in. Websites, Bash, Socket, using Turtle and Python, Boom Game Engine, lots and lots of tutorials built right in. Community, so there's sort of a social media aspect to it as well. You can kind of look on different things there. And then this is social media thing. It's a place to raise money, some crowdsourcing things. You can go ahead and do that to raise money for projects. If you have a big project in mind and just don't have money to finance the big project, it's a place you can crowdsource funds as well as other programmers to work on the project. Templates to get started with different things. It's kind of what we're going to go to. Let's go back to the home page. Bunch of different things. So you notice up at the top left there, there's a button that says create. And that name, that's what they call the different programs we create. And then you'll just want to choose some sort of language. So we've been looking at Python, so something else this here, C++. Let's look at something in C++. And it'll generate a name if you need it, and go ahead and create it. I don't need that. So right off the bat, it tried to start typing some code. Pretty much everything in the C++, we're going to need some sort of external libraries included. So even for our most basic one, I'll just leave it like it was. Can't remember the name of the library I wanted to import there. It'll be okay. So we always have to include some sort of library. And a lot of our programming languages are going to look the same, which is sort of what my general recommendation for that section this week is going to be. Take some programs you've already written this semester and use and reapply them in a new language. All you need is the syntax. So like in C++, all you need is the syntax. Something that you've already done in Python, one of the quick, easy ones, probably from the beginning of the semester. Right, the closer you get to the beginning of the semester, the smaller the programs were in general. But take something you already did in Python so you know how the logic works and try to make that in the syntax of a different language. So that you get a nice little test of how the other language goes together and compares. So C++ is a version of C from the C family. It's object-oriented. So everything has to start in this function called int main. That's built in. We have to set up a method called main somewhere in our file that the compiler will look for and start running the code there. And then we have some curly braces. Curly braces define blocks of code. So in Python, what we've been doing with indenting, if we have like a selection structure, then when that condition by the if word keyword is true, there's a whole bunch of indented lines that all run together. Those indented lines are a block of code. So here in the C family, we use curly braces to specify what when things go, when instructions go together as a block. We also have a semicolon, which when you're writing your code, it always goes at the end of the line in the text file. So the best way to think about that, getting used to it, is the semicolon is the character that means end of instruction. So you're typing that and reading this line, we have this instruction. So use the standard output, the standard console output, and we haven't seen that operation. I'll talk about that in a second, but then we'll put the words hello world to the standard output. And then that semicolon means end of instruction. There is a technicality that by the time that gets compiled and turned from text file, high-level programming language in a text file into some actual machine language that the computer can actually run, that order switches and the semicolon represents next instruction, not end of instruction, but because of where we put it in the text file, it doesn't make any sense there. But there is a technicality that you may need to be aware of later, and I don't want to just, I want to make sure and state that technicality, that when that compiles, that becomes that's the symbol for next instruction. But because of where we put it in our text file, it's going to make a lot more sense if you think end of instruction when you type that semicolon for now, especially starting out. We have not seen that operation in our in anything we've done in Python. That's going to be the biggest one if you look at C++ this week. And that is our bit shift operation. Let me draw a picture on the board. So y'all are familiar with, talk about binary code somewhere along the way, right? So if we have, like, say, the letter A, then that's actually ASCII code or Unicode value number 65. So it's going to look like 0, 1, 0, 0, 0, 0, 0, 1. C, that's another one that worked. I'll do AC. So if capital A is 65, 66 is B, 67 is C. So 128 is 64, and we need 3 more. So 0, 0, 0, 0, 1, 1 gives us 67. So that's what we actually have if we write the string AC. AC is actually the string 0, 1, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 0, 0, 1, 1. So we have all of those bits. And you're used to things like Python where we have the print statement. All this stuff's built in the background. But when we want to print this out, what we really need to do is move these bits, because, well, when they're in our code, like stored in a string or something, they're in RAM. But we need to get these bits from RAM over to our output. So maybe we have this variable myString that holds the string AC. So we need to get that from our code over to the output. What we actually have to do is move these bits to the standard output through serial communication. So it moves one at a time. And that's what our bit shift operation is. So bit shifting, if we do that once, everything shifts one spot over to the left in this case. So we got rid of that first 0, and over here we're left with 1 0 0 0 0 0 1 0 1 0 0 0 0 1 1. Except that now we're a bit short because the 16 bits was based off two 8-bit things. So we need to have 8 bits in every spot that we have to hold bits inside our computer. If we move one over here, then we're one short. So we'll add another 0 there at the end. And then we'll do that again. Shuffle the bits, and then the first 2 have moved over. And then 0 0 0 0 1 2 3 4 5 2 3 4 5 1 0 1 1 2 3 4 1 1 0. And again, we move things over, so we're a bit short, so we add another 0 on the end. So that is the operation to actually take the bits representing our data and move them over someplace, one bit at a time. We don't use it as much as what we once did with programming, but it is still heavily used in the C family of languages. We still use it a lot in C++. So that's what's going on that first line. So we have this string as hello world, and then a new line character, and we're just going to shift all of those bits over to our standard console output. So when we run that, it goes through the compiler, creates it, and then shifts those bits over to our output. That's also how we get input. It kind of goes the other way. Enter your name. And then I'm gonna take out the new line. Colon, and then we'll do that. We'll shift that out. And after we shift that out, well, then we can get something coming back from the user. I think I can use a string here. Can I use a string? Oh, let me look this up. Which namespace in C++ has string? So I think that's the same one I need the other way. Oh, include string. Wait, was that not it? Look over here. Oh, I need the standard input string. So this week, you're going to see a lot of things, different syntax. So standard input string goes from our standard input CIN. So notice we had C out and then C in and shuffling bits. When we start that as a blank string, and then our standard input shuffles over to username. And there's our input and output. Very, very different than how we do it in Python. Those pre-built things in all the high-level language. We're a lot closer to the machine. Obviously, as long as C++ has been around, there's lots of methods to use it. But the default is still to use that standard console in and console out, the standard input and output for the system, and actually use bit shifting on the Unicode values to move those back and forth into those strings. Then we could build up another string. So our standard input, so what's really going on here is that's another library, like we used in Python, right? If we import, last week we were looking at the TK interface package. We import TK enter, the abbreviation for it, and lots of different ways to pronounce that. I usually just go ahead and say the whole thing. We import that standard abbreviation for the TK interface package, which is a lot of letters to type. So usually we throw in something like as TK to make it easy to type. And then we'd say like TK.button. Well, that's the same thing we're doing here. It's just different than those colons are different than the dot. But we're referring to a library, something in the library. A string in particular, string type of data. String message is assigned hello there plus whatever stored in username. So the rest of that probably looks familiar. And then we can use that bit shifting to send it back out. So our standard in-out library has something called C output, and we will bit shift to the left. Notice that our output goes left. We take our string and shuffle all those bits to the output, and our input goes the other way. We take a spot to store a string, and then all the stuff from all the bits from our input get shifted into that. So the bit shift, that's the bit shift operator. And most of the languages you've seen have probably somewhere along the way already built a method that used that and put it in the background. So all we need is the words. Then we'll shift the Unicode values making up this message. We will shift those out one bit at a time onto the console. Enter the name. So if I type in my name, get that message shifted back out. That's probably very different than anything we've seen before so far this semester. But lots of different syntax. We just saw a colon there for object stuff. Colon kind of looks like dot with a library in Python, but it doesn't just take the place of the dot. We actually have a lot more things we can do. Dot is also like the dot we use in Python. And an arrow is also like the dot we use in Python. Python with more control over how it's stored in there. We have a lot more direct control with C++. There are some big advantages to it. That quick example probably looks like a mess. But that is definitely one of the languages you'll want to take a look at. Go to YouTube and at some point this week, go to YouTube and Google getting started with C++. Usually the words getting started work really well in the Git videos. You can probably find a good 20-minute video, 3-minute video, hour, 20-minute video, 12-minute video. For the stuff this week, it's very much preview mode, so I would say don't go over a 20-minute video. And it's videos about coding, so you can increase the speed and use the pause button would be my recommendation. Instead of watching it as at normal speed and trying to type along, increase it up to like 1.5 times speed and just hit pause and jump back over to wherever you're typing. But you want to do some stuff like that and use the keywords getting started in the search and look for some tutorials and see what it's like using the language. Because there's also a namespace. I couldn't remember what it was off the top of my head, but there's a way that we wouldn't have to do SDEV. Oh, it's using. I was trying to include, and I should have done using. Using SDEV. Nope, that's not the right word. Like that. Well, I'll look it up. Oh, so it looks like we have to use it for each particular one. That's not the way I normally type it, but that will work. So I should be able to say using STD requires a qualified name. Okay, I guess I have to do this. See out. Using STD : string, and we can set them all up this way. Lots and lots of different tutorials. I'll just leave it like it was. We can also type it right there, and then we don't have to worry about multiple ways to import our language and stuff. The big thing with C++ is we have unrestricted control over the machine. If we write code that will make the machine self-destruct, that code will run. And the machine will self-destruct. No warning messages or anything. Complete unrestricted control over it. So that's a good language. That's still a very popular language. There's some other stuff. We've known about it since people first started doing object oriented and stuff in C. But for some reason, there are things that are faster in C than they are in assembly language. Over the many decades, people have come up with a lot of theories, but there's never been a conclusive explanation on that because it doesn't make any sense. Assembly language, which is working at the machine level directly, should always be faster than a high level language. But for some reason, there are a number of places, and we've known about them for many decades because people have set timers, and C++ is faster than actually doing it in assembly language. It doesn't make a lick of sense, but a lot of computer scientists have tried to throw out explanations that are really just lots and lots of words. So lots and lots of big words. So it sounds like they know what they're talking about, but it doesn't thoroughly explain it. But it is the language that gives us by far the most control over the machine. Most direct control over the machine. So that's one you might want to look into this week. Java is quite popular, C#. There's lots and lots of different ones. And really, if you come over to wherever the homepage is, that's not it. How do I get back to the homepage? Do I go here? There we go here. Okay. I'll close out of that one, go back to the homepage. If you go hit the create button, you will see there's lots and lots of languages to work with. Node.js, that's JavaScript modified slightly so it runs on a server. C#, a couple of y'all were in this afternoon's class when we did the 45-minute passes, the basic C# syntax. So maybe that would be a good one to look at. Use C# and that pass we did at the syntax earlier today, or maybe other tutorials, or quick look at the syntax and see if you can duplicate some of your programs from earlier this semester in that other programming language. Then you know then you're doing something that you've seen the logic with and just need to apply it. React, Ruby, Blank, Swift is Apple's proprietary language. So if you're at all, if you want to work for one of the big companies, C# is actually Microsoft's proprietary language. So if you ever have hopes of working for Microsoft, you'll need to know C#. And same thing with Swift. That is Apple's proprietary language. So if you ever want to work for Apple directly, that's the language you would be required to write, to work in. Go, Google has really been promoting Go. Google knows lots and lots of languages, and they're not strict, not restricting things. They're not saying you have to use Go, kind of like Apple and Microsoft do. But Google is quick to say that they really, really like it. So that's what they want you to use. That's another good one to look into. Lua is very similar to Python. If I click on that, I don't need all the ads. So if I open an example, okay, here's a factorial example, a recursive call in Lua. That looks very, very similar to what we were doing in Python, right? A whole lot of the keywords line up with what we did in Python. And again, white space matters there. So very similar to what we did in Python. That might be a good one to look into. What else we got? Great. Ruby's been popular for a while. It kind of comes and goes. Clojure, Haskell, TypeScript. Rust is really, really fast. In general, most languages have certain aspects that they'll be faster than others in. Rust tends to be faster than most programming languages across the board with everything it does, even the big things. R is sort of a statistical analysis thing. Dart. Kotlin is, that's a language Google developed. And then they were promoting it heavy for a while, and then somebody else developed Go, and then Google decided they like Go. You'll still see it a lot. Flask, that you'll see Flask at some point. I don't need to dive in there very far. Visual Basic, Java. But you can see there are lots and lots and lots and lots of languages on here. And when you click on one, so Ruby on Rails. There's no example here. There we go. it starts, most of these have examples. That one did not have examples. I was expecting that to have examples on it. Let me go back and click on one that wouldn't have an example. Yeah, that's fine. Create a new one, maybe Java. So C++, the one we looked at a moment ago, we have, the programmer has unrestricted control. There's no limit. We can overload operators. If we decide we have another thing we would like to do with the plus sign, we can just give the plus sign something else to do and give it another meaning. Unrestricted control in C++. But when programmers have unrestricted control, the language quickly turns into an unwieldy monster. So in the early 90s, they realized that total control over what we do, the programmer does with the language, was kind of bad. So they started cleaning it up and adding in, really what they added in was warning messages. We still have the full capabilities, but we can't automatically run code that's going to destroy the machine. If we write code that's going to destroy the machine that's running on, we have to at least ignore a warning message in order to run it. That sort of cleaning it up. We still have the full capabilities. It's just nicely organized and it's not a complete unwieldy monster. You don't have people going around and changing like what the plus sign is used for and deciding that they want to use plus for they want to use plus for that thing we saw a minute ago, the standard output, standard console output. It's like, that's a lot to type. So let's just make that the plus sign. We'll use the plus sign and then go to the standard output. And it starts to get confusing because we also use plus sign for concatenation and plus sign for addition, as well as accumulation, which is like an incrementer. That's a lot of different things that we can use that one symbol for. It gets confusing very, very quickly. So this starts with just a simple, what a hello world looks like in Java. But again, there's examples built in you can use right here, or back on the home tab. I'll go back out here. There's tutorials built in right here, built right into the IDE. You can follow some of those, check things out on YouTube, but in general, it's just look at other programming languages. We finished up our section on Python-ish. We're probably still going to come back and talk about being a Python project is due on Python, but in general, we're going to be looking at other programming languages now. So you'll want to look around in a preview mode, look at the syntax for another language, and try to replicate some program you've already made. Like something from earlier this semester or previous semester that you have the logic worked out and how to put that program together in Python, and then do it in a new language so that you can kind of evaluate, compare, see which ones, see the differences, compare how long it takes each one to run, which is faster, slower. And in general, it's just sort of a preview of it. Get familiar with what's out there. Take a look at which languages have curly braces and semicolons, which ones make the semicolons optional, which languages get rid of semicolons and curly braces like we did in Python. And when they get rid of, they don't use semicolons and curly braces, what do they use to create blocks of instructions or to define where a particular instruction is? Which I guess in general, that question is, what does white space mean in our script? When we write that text file in the programming language, what does the white space mean? In Python, it's critical, right? I'm sure by this point, everybody has seen several indentation errors in Python and had to go back and fix the missing white space or the extra white space. There's the C family of languages, white space does not matter at all. white space actually gets deleted when it gets compiled. So the white space doesn't matter for anything there. So kind of look around at those different things, see what you like or don't like about different languages. And the easiest way to do that, it's an active subject week, is by doing it, by actively doing it. So take some of your Python code from earlier this semester or previous semester, things that you've already written. My go-to for a new language, I've done it many, many times. I make a classic game, Space Invaders. Make the bunch of aliens coming down from the sky, move back and forth, and you have a cannon shooting up and try to shoot them. And every time you destroy one, they move faster. And every so often they get closer to the ground, move faster and faster and closer to the ground. And the speed increases and they get closer to the ground and eventually it destroys it. That's what I write every time I think of learning a new programming language. Because I've done that so many times. I've made that game so many times, I don't know how to think about it at all. I know that logic. I can type up that logic without a leak of thought. It's almost instinctual. I've done it so many times. And that's what I use to learn a new language. Is that way it's not just a generic syntax example. Taking something that I know the logic for and applying it in a new syntax so I can make a nice solid comparison between that and the languages I do know. So maybe try to think about what a good program that you would know really, really well to test out new languages would be, and give it a few tries. At this point, you probably think it's something small like a payroll calculator or a sales tax, and just do that simple thing that you know how it works in a bunch of different languages to get a preview of the other languages. That's the big thing for this week. Something other than Python. There will be a programming assignment come out after Wednesday's lecture, depending on what we cover in Wednesday's lecture, will make the difference there. Otherwise, it's an active subject we learn by doing, so you want to take some time and do that. And that's my recommendation for the next 15 minutes. Start clicking around on like Ripple. The people who made that were Czechoslovakian, so E is pronounced like the letter I, so they actually called that Ripple when they made it, but it's spread worldwide. It's not just an Eastern European thing anymore. So again, you'll hear lots of pronunciations. I would have pronounced that Ripple, but because of the Czechoslovakian, the way they pronounce that word, it was originally Ripple, is how they say that. So if you go to Ripple IT and give some different languages a try, that's my recommendation for the next 50 minutes. As always, until our scheduled block of time ends, I'm just going to be sitting here waiting for questions to come my way. I'm pretty sure I'm the last person on campus right now, except for maybe a janitor and a security guard sitting around waiting for me to leave so they can finish up their days too. So if nobody sticks around at the end of the Zoom call, I might take 10 minutes to drive back to my home in Clarksville. So it'll be 10-minute gap, but otherwise, text messages and Ivy Learn messages are the two things that make noise on my phone. So definitely the quickest way to get a hold of me. Does anybody have any questions before we wrap up here? Okay, I assume 5 seconds of silence means no questions. If you have any, let me know. I'm always happy to help. And that's kind of what we're doing this week, is looking at other things. GitHub, that's not the different tools that we'll use in software development, not just the coding. And as far as coding, we're going to look at different languages. So treat them all in preview mode. Don't get stressed about them. Don't worry about them too much. We're just previewing the other languages now that we finish the Python part. Otherwise, I'll see y'all on Wednesday. You have a great evening. And yeah, I'll see you Wednesday.